In today's lesson, we are going to be looking at bad graphs. So in the previous lessons, we've looked at how to collect data, how to analyze data, different ways to display data, how to analyze the graphical displays, and now we're going to look at bad graphs, or basically ways that graphs can misuse or mislead us using accurate data. So looking at a little bit of a warm-up, we're going to do some true and false. So true or false? The sales are rising rapidly. So take a look at the graph and think about whether you believe that it's true or false that the sales are rising rapidly. Now, you may have looked at the graph initially and said true, but hopefully if you took a further look at it, you said false, because if you look at the Y values, you can see that they're not going up by much. They're only going up by 10 every time. So 10 sales, or an increase of 10 sales every year, is not what I would classify as rising rapidly. Next one. True or false? There are more 15-year-old boys than girls, based off of this graph. Based off of this graph, though, I would say that it's false, because when we're looking at a pie chart or a pie graph, the sections aren't referring to the number, it's referring to the percentage. So we don't really know how many people in total we are looking at here, or in each group, so we can't really say that one is larger than the other. We could say that there are more 15-year-olds in all the girls than there are 15-year-olds in the boys, but in terms of the actual number, we don't know for sure. True or false? Twice as many people like thrillers than romance films. So again, do we think twice as many people like thrillers than romance films? And looking at this graph, well, looking at the graph for the bars, you might say, yeah, that looks about right. But again, if you look at the scale, you can see that the scale is not consistent. The scale is not consistent. We go up by 15, then by 5, then 15, then 20, then 40, then 20, then 30. So because we're not increasing by a consistent amount, we can't make those claims that thrillers are twice as many people like thrillers compared to romance. True or false? Most people took between 20 and 60 minutes to get to work. So this one might be a little bit trickier, because this is a different type of graph than we've tend to see, but we have looked at histograms before, which is what this is, because there are no bars spaced between, or there's no gaps between the bars. But in this case, most people did not take between 20 and 60 minutes to get to work, because the height for this bar is only 25. So that means 25 employees took anywhere between 20 and 60 minutes to get to work. So just because the bars are wider does not necessarily mean that it means that there's more people in it, right? Because we're still looking at the specific height levels of our bars to give us an idea of, again, the number of people. Right, so if we were to take that bar or that histogram and look at what it actually represents, we would see that, again, the majority of people fall within this interval. So when you're looking at histograms, it's not necessarily the width of the bar that represents the larger number of people, it's the height. So again, it could be misleading, because the numbers aren't false. It's just how we're displaying them that tend to be false. So we're going to look at some things that can make graphs misleading. Now again, it's not that the data is false or the data is fake, it's how it's presented that's making it misleading. So one, if a scale is too narrow or there is not a big enough range, data looks like it has a big difference when it does not. So if scale is narrow or not a big enough range. So if we look at this graph here, hard at work, payroll employment in the millions. So if we see the recession in this spot here, and we see that it looks like there's a tax cut, and then it increased the payroll employment, so basically increased employment. But if we look at the actual scales, it's only going up by 1 million every line. So it's really not increasing that much, especially if you're considering a country as a whole. 1 million in terms of employment for an entire country isn't really that much, or it's not as much as the graph may make it appear to be. If there is no scale at all, so sometimes you may see a graph displayed with no scale at all. Right? So that is again misleading as well, because you have no idea if it's actually proportional to the rise or to the increase or decrease that they're displaying. So in this graph here, the Trans-Pacific Partnership is estimated to grow U.S. national income by $131 billion by the year 2030. Right, so we can see where we start, we can see where we end up, and we can see where we would end up without this Trans-Pacific Partnership. But again, because there are no scales on the side here, we should probably use a different color. Because there are no scales on the side here, I don't really know if this is an accurate level for both of those values. Right? And realistically, if we look at the values, 25,754 billion versus 25,885 billion, maybe it's not that much of an increase as it actually seems. So again, no scale makes it hard to actually accurately see the increase or the change. If the scale is truncated, which basically means it's cut off at the bottom, that can be misleading, because again, it's showing that maybe there is a larger increase than there actually is. If we look at these two graphs on the right, or on the left, sorry, over here, they're the same data, just looking at a different y-axis. We can see one starts at 3.14 and one starts at 0. Looking at the two values, or the two graphs, one looks like there's a drastic increase, and one looks like there's almost no increase at all. So again, the scales are proportional. They're increasing by the right amount, or by the same amount every time. The data is the same, it's just one starts at 3.14 and one starts at 0. So again, it might be a little bit misleading in terms of, again, how big is the increase actually. Same thing with the graph on the right. Looking at, should Britain leave the EU? Again, we've started at 37%, and we've increased by 1 every time, or 1% every time, which again, that's a fine scale, nothing wrong with that. But it's a bit misleading because it's showing a larger increase than there actually is, or it's making the percent they want to remain appear much smaller than it actually is. If we saw everything down to 0%, or the full range of the values or the percentages, again, the bars may not seem that different. And if you look at the actual numbers, they don't seem that different, or you can at least tell they're not that far apart. But again, if you see this shown up on the TV or in an article or something like that, you're glancing at it mostly. You're looking at the bars. You're not reading. You might not read the numbers right away. Next, if bars are not equal width, so looking at semester 1, semester 2 grade point average, looking at the barrels in millions for two different countries, we have different bars. Again, we've seen an example in the warm-up where the different bars tend to be misleading and making us think that there's more people in there when there actually aren't. So again, if bars are not equal widths, then it can be misleading. If the intervals on the graph are not equal, but are depicted as equal, again, we saw examples of this in the warm-up. We can see, okay, it looks like the data is normal right? We see it over different age groups. We see the risk of death after catching the coronavirus is on par with the normal rate of male, or the normal male death rate and normal female death rate. But again, because the y-axis, or these scales, are not increasing by the same amount, right, we don't actually know what this really looks like. So we would need to see an accurate scale to actually see what the actual relationship is between them. If we're looking at a pictogram, right, they can be misleading if all of the pictured items are not the same size. So it's okay to have a pictogram. Maybe it makes it a little bit more appealing, but you want to make sure that the images or the pictured items are the same size, right, or relatively the same size. Right? If we look at these different graphs, we can see the large barrel again looks to be quite larger. Maybe it is double in terms of the actual values. So you might say, okay, well that makes sense because it is doubled, so it should be larger, double the size. Fair enough. If we look at the average female height though, looking at the maximum or the highest, we see it's at 55, or 5 feet 5 inches. But if we look at the second one, 5 feet 4 inches, it looks like quite a drastic drop. Even down to 5 feet 2 inches, or 5 feet in general. Looks like quite a large drop between the different countries. But really, 5 inches isn't that much of a drop. Definitely 5 or 1 inch change is not a large drop. Definitely not as noticeable as this graph makes it appear to be. So again, it can be misleading if all the pictured items are not the same size. So what we're going to do is look at some examples of graphs and think about why they're misleading. So if we look at this graph of a knuckleball velocity, see in 2012, 2013, it looks like there's quite a large drop. So why is this graph misleading? Well, there's a couple things. You could say it doesn't start at 0. So if it doesn't start at 0, we don't get an accurate visualization of how much there actually is there. You might also say that there's no scale. Right? If there's no scale, it's hard to tell what we're actually looking at. So again, the scale might be very, very small, or we're increasing by small amounts, which makes a small drop appear to be large. So again, we need to be careful with stuff like that. Looking at the next one, so looking at a scouting report of the usage of certain pitches, see the knuckleball is 89% and the fastball is 10.5%. So this one is a little bit more obvious, because again, looking at the numbers, we know that's not true. But you could say there's an inaccurate scale, because clearly the scale is not increasing by the same amount. Otherwise, we would not see this close of a height difference. So inaccurate scale, you could say there's no scale. Maybe it's truncated. Again, we can't really tell because of the fact that there are no scales. Looking at the next one, gun deaths in Florida. So looking at the number of murders committed using firearms. So it looks like, okay, it gets relatively high, and then as soon as Florida enacted its Stand Your Ground law, which is a controversial law in itself, but nevertheless, it looks like there's a drop. So gun deaths dropped significantly after that. But if you take a look at the graph, you see here, looking at the actual scale, they've actually inverted the y-axis. So they've inverted the y-axis to make it look like it's actually decreasing when it's actually increasing. So again, the scale is fine, the data is fine. They've just, for whatever reason, or well, not for whatever reason, they've purposefully inverted the y-axis to make it look like it's decreasing when it's actually increasing. So a somewhat simpler one, student drink preference. So looking at number of students, looking at the drink types, what's misleading about this? Well, there's no scale. There's no scale on the y-axis. All the bars are the same size, so that's fine. We can clearly see them. We assume that they start at 0 based off the axis, but there is no scale. So I don't know if the first line represents 10, and the second line, again, we're assuming it should go up by an equal amount, 10, 20, 30. If that is the case, there is a larger difference from, say, 15 to 10, rather than if it was going up by ones. So again, the fact that we don't have a scale might minimize what the actual difference is. Some more examples, again, just to look at. Again, we can see another pictogram looking at the height, but if you look at the actual scale, there's not that much of a difference, right? If we're looking in terms of centimeters, right? So we're going from, say, 1.85 to 1.75. So that's really only 10 centimeters. If you look at 10 centimeters on a ruler, it doesn't look as drastic as what we see here. So again, the pictograms, if they're not the same size, which again, they may not be because you need to show the different heights, it just might be misleading. As well, we're not starting at 0. So that is another difference that makes it appear that they're quite smaller when they might be, or the difference might be very minimal. Looking at a bar graph, looking at the percentage of people that like certain toppings. Again, this one we can see that one, the slices aren't even, or they aren't proportional to the percentages. Two, we can see that the percentages don't add up. So it doesn't quite make sense in terms of what they're showing here. It's almost like they just wanted to show a picture of pizza rather than actually have an accurate graph. So maybe they figured that having an image of a pizza might be more appealing, or might get people to look at their image or their graph rather than a proportional pie chart. And lastly, one more, so looking at which countries directly import the most Russian natural gas. So looking at this, you might say, okay, well, it doesn't seem to be anything too wrong. We have the different circles to represent the different imports, different colors to represent the different countries. It does start at 0, it goes up by 10% every time, so we're seeing everything. But if you look at the x-axis is just the alphabet. So really, what's the point of having these countries spaced out like this, right? It's not that the data is wrong, it's just why is it spaced out using the letter that the country begins with? It doesn't really make sense in terms of what you're trying to show. Right, so you almost think that there should be a second variable here to kind of create almost a scatter plot of some sort. But again, the data in the graphs may not be false. It's just how it's presented that can be a little bit misleading. It might get you to interpret the data differently than you would if you had full access to it. So again, the idea is that you want to be careful. You want to make sure that you're critically thinking and reading graphs carefully to fully understand what they're trying to show, or see if the author, whoever's presenting the material, is trying to mislead you in any way. And then we had the examples and some key things to look for, or common things to look for, that people might do or use to try to mislead you a little bit.